Welcome to the Stormsurf video surf forecast for the week starting Sunday, January 28th. Looking at significant wave heights for the North Pacific Ocean, we see not a particularly strong storm pattern in control. Low pressure off the Pacific Northwest is trying to generate some seas, but nothing of interest at this moment in time. Another low pressure system in the Northwest Pacific is generating seas in about the 33, 34 foot range, but all aimed back at Kamchatka. Nothing aimed at U.S. or our forecast area. And then high pressure generating strong east winds. Trades, basically relative to Hawaii, probably generating some wind swell. But that's about it. Let's get into the details. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet. And the only dip we see really is right here in the Gulf of Alaska. And winds, one little tiny pocket of 130 knot winds. It's these winds in the southwest quadrant. That really is what helps fuel storm development and generate swell relative to our forecast area. And that isn't very much right there. But that is a trough. We'll take it for whatever it's worth. But the main flow, pushing pretty well off of Japan. Winds was at 170 knots. But notice it sort of splits over the Aleutians and splits definitely out towards the dateline. All that wind pushes well to the north and out of the picture. The return flow then falls south off Alaska, joins the main flow, which then splits again, some of the energy going up towards British Columbia, some of it falling south towards Mexico, yet splitting again with some of that energy moving towards the equator. The reality is this is a very fragmented, messy jet stream pattern, not indicative of a strong storm pattern whatsoever. So let's roll out, see what happens. We go out into Monday. Again, the big split becomes more pronounced over the Kuril Islands. Nothing going on there. Double, if not triple split east of the dateline. Little bit of a trough here tries to organize, but remember there's a split going up here. So how effective is this little trough going to be? Well, it's got a pretty decent amount of wind energy flowing into it there. What is that? 150, 160 knot wind. So yeah, maybe support for low pressure development. And then things get a little bit better because it looks like the split in the far west Pacific starts fading as we get into Thursday, and a trough starts building on the just east of the dateline, being fed by 190 knot winds. Notice the split point now. There's only one split really, and it's off about 150 with part of the 150 west with part of the energy moving up into British Columbia. The other part moving down towards the equator. Under this, high pressure rules supreme. That locks out weather for all of California. But it looks like there is still some hint of a storm track pushing into, let's say, British Columbia. Anyway, roll this out. The trough continues as we get into Saturday over the dateline, and then we get into Sunday. We're almost a week out, and that same pattern holds. High pressure over we'll call it the southwestern United States, still in control. We'll go to, there we are, a week out. Now, the good news here is the split is supposed to be completely gone. The jet flowing pretty healthily or strongly over the dateline. Healthily, not a word. Anyway, dipping down a bit of a trough there north of Hawaii. And then, yes, the split's still present, but not as bad. It almost appears as if some energy is going to try to work its way into the U.S. West Coast. Probably not. The main focus of weather activity will probably be British Columbia or so. But the thing to note here is all the split activity that was in the West Pacific is to be gone. The assumption is the inactive phase of the MJO, which is in control right now, that steals energy from the jet. That's what causes that multiples three-way split pattern we saw, is to be gone. And perhaps the active phase is to be forming in the tropics in the West Pacific. That feeds energy to the jet. The jet then pulls itself back together. It's stronger, and it doesn't split, and that helps feed a progressive storm track. So we're going to pay a price for the next week, but about a week from now, the picture looks much better. So let's take a look at what's going on down at the surface. Surface level pressure, surface level winds, and as expected, low pressure is in the Gulf of Alaska. Actually a gale 45-knot winds, and almost a storm. There's a little tiny pocket of 55-knot winds there, and almost looks reasonably consolidated, maybe helping to support swell production. Now also, low pressure is off the Kuril Islands, but again, this is not looking good. All the energy, see there's high pressure, 1040 millibar high over the Bering Sea. That's producing a pressure gradient in conjunction with low pressure here. The closer the two, high pressure and low pressure, get to each other, that tightens up the isobars, that creates wind, but you see all this wind is pretty much pushing off to the northwest, not doing anything to produce swell for anywhere other than Kamchatka. So let's roll this out, see what happens. Our low continues in the Gulf into Sunday night, into Monday morning. What was that? Oh, there we go. Little patch of 40-knot winds, going up and then falling to 35 knots, and then pushing into the British Columbia coast on Tuesday. Low pressure, let's actually go back and look at this. Now notice we get a little bit of fetch starting Monday over here in the southwest quadrant of this low, somewhat targeting Hawaii with a tiny area of 40-knot winds, and that up to 45 knots by Monday night, and falling pretty well to the south-southeast. So maybe some swell could result from this relative to Hawaii. And look at this, as we get into Wednesday, that fetched 35. Let's pull this away and take a quick look under there. 35, almost 40-knot winds, moving very close to Hawaii. And then another fetch builds behind that on Wednesday. Again, another portion of 40-knot winds aimed directly at the Hawaiian Islands. Broad low pressure filling the entire, we'll say, middle part of the North Pacific with fetch aimed at Hawaii. So the thought is, of course, as the jet stream starts building, the trough builds here, that supports low pressure at the surface, and you start getting this progressive pattern of low pressure systems moving very close to the Hawaiian Islands, possibly bringing weather there as well, and high pressure in control of the U.S. West Coast. Anyway, here we are Saturday, still 30-knot winds blowing right at Hawaii. Looks like a good long run of surf is possible, and yet then we get into Sunday. Notice a storm, 50-knot wind, starts building off Japan. We know the jet's raging right across here with a trough somewhere in this area. That likely will be generating, there we go, yet more fetch and more swell, with Hawaii being the prime target. California could receive long-distance energy from this, but with high pressure locked over this portion of the United States, a light weather pattern and no rain is forecast. All right, let's go take a look at the effect of these winds on the ocean surface. And here we are, significant wave heights for the North Pacific Ocean. We already described the first frame of this, so let's see what happens. A little bit of seas, what's that, 20, 22, 24 foot, 25 foot seas. As we get into Monday, aimed somewhat at the U.S. West Coast, as well as possible. This system here only producing seas pushing towards Kamchatka. We write that guy off until we get into Tuesday, a small area. Remember, we saw that fetch developing there. 32, 33 foot seas starting to fall towards Hawaii, holding in that range and then fading. What are we down to 24 foot seas or so as we get into Wednesday? But another system, stronger, really part of the same low, just a progressive low pattern, builds broader area of 33 foot seas pushing towards Hawaii, but now moving to within, well, let's see, that's every one of these is 300 nautical miles, or every 5 degrees north-south, so 600 nautical miles, and sort of draw an arc, we'll say maybe about 800 nautical miles out, 30-foot seas, and just continually pumping at least 18 to 20-foot seas, even Saturday night. You can see seas impacting the Hawaiian Islands. So we get into Sunday, and then the new system pushes off Japan as we're all a week out now, Sunday night, with nearly 40-foot seas, barely right there, right in the center. So Hawaii looking to receive a good amount of swell energy, some of it likely very raw given the close proximity of these systems to the islands, and far less energy for the U.S. West Coast, but also far less odds for weather to interfere with whatever swell does arrive. Let's take a quick look at winds for both Hawaii and the U.S. West Coast. You can see, zoomed in here, high pressure in control of the California coast, light north to, we'll call it north-northeast flow in control of North and Central California. Relative to Hawaii, Northeast winds, won't call them trades. Northeast winds in the 10-knot range. Let's just sort of roll this out and see what happens. Some sort of low pressure system, almost looks tropical in nature, pushing north off the Hawaiian Islands. Trades, except relative to Hawaii, more north, almost Kona winds. But otherwise, on Monday, light offshore flow looks like for California, and then more of the same for California. You see this bulletproof high pressure system in control here, split jet stream flow. But this low is like on the leading edge of this building low pressure complex that's setting up over the dateline and just west of the dateline. There we go. Southwest winds starting to build into Hawaii come Tuesday night. Again, sort of a more north wind flow building off of California into Wednesday. We'll roll this out. You can sort of just watch southwest winds over Hawaii as we get into Thursday. Sort of a north-northeast, just a straight north flow relative to north and central California. Bulletproof high pressure still in control of the whole U.S. West Coast. And the southwest flow looks like it persists for Hawaii. And we just roll this out, really just variations on the same theme. And then again, looks like a front pushing into Hawaii on Sunday. And where are we at? We're at 180 hours, so no significant change indicated here. Let's do a quick look at precipitation, though we think we know the outcome. Here we go, precipitation, and we're really focusing here on California, and we don't expect to see a whole lot. Now notice the line between dry and wet has so far this season been between Oregon and Washington. Yes, there is precipitation making it south, but there is significantly more precipitation from this point northward, especially as you get into southern British Columbia. And let's just see. Continued rain. There you get. You can just see the line. It doesn't really change. Just nothing can make it south because high pressure is blocking the storm track completely till we get into Sunday, and then the dry line pushes even further north. But 180 hours out, still, British Columbia getting precipitation, but nothing south of there. So no rain, no snow in the forecast for California for the next week. And relative to snow levels from personal observation, even though there have been storms that have made it into the Tahoe region, it's still pretty obvious that the freezing line is from 7,500 feet and above in the Lake Tahoe area. Yes, there's snow down to the ground in the Lake Tahoe area, and some of the lifts, lower lifts are open, but it is rocky indeed below 7,500 feet. Above that, though, good conditions, not bad, and certainly not like last year, but it is skiable and boardable. All right, let's take a look long term. What's the outlook? Let's see what the effect the MJO is having, and of course, what's going on with La Nina. As usual, we start inspecting winds over the equator, mainly in the Kelvin wave generation area. So that's New Guinea there. There's the equator. This is the East Pacific, West Pacific. It's the area from 135 east out to about 170 west, 5 degrees north and south of the equator. That's the Kelvin wave generation area. When you have west winds in this area or westerly anomalies, that helps push warm water to the east and creates a thing called a Kelvin wave. And that's an early warning sign of either a strong active phase of the MJO or perhaps the onset of El Nino. Right now, trades are in control of the entire equatorial Pacific, including the Kelvin wave generation area. And then we look at anomalies, differences from normal for this time of year. And yes, even in the East Pacific, winds are slightly stronger out of the east. And as we get into the Kelvin wave generation area, right again in here, yes, anomalies are from the east, suggesting the inactive phase of the MJO, and we, of course, know that is, in fact, in control right now. And that is what is causing the jet to split. These easterly anomalies, steel winds that would otherwise, or steel wind energy, or precipitation, moisture energy that would otherwise be rising up into the atmosphere, feeding the jet stream, instead steals it from it, causes the jet to split, and you have exactly what we have right now. Next up, 850 millibar wind anomalies going back 5 days. Kelvin wave generation area. There's Australia there. There's the Philippines there. South America there, Kelvin wave generation area, 135 east, and there's the equator right about there. So we draw a little box right in here. You can see easterly anomalies. Yeah, easterly anomalies, maybe a little bit of westerly anomalies, maybe a little bit of more building westerly anomalies. You can see most of the westerly anomalies are here in the Indian Ocean. This is out on January 26, suggesting the active phase of the MJO is probably somewhere right around here over the maritime continent, trying to perhaps make its way into the West Pacific a little, while right here, this, and you can just look up here, right around in the same area, basically the inactive phase of the MJO is over the date line. So it seems like we're probably at the peak of the inactive phase of the MJO, or maybe just a little bit past that, and maybe the active phase of the MJO, just looking from this chart, just eyeballing it, is trying to make its way into the West Pacific. So let's zoom in a little closer. 850 millibar zonal wind anomalies. This is what's been happening since January, the whole month of January, you can see. Okay, and tick marks right there. That's 120 east. That's the date line there. So the Kelvin wave generation area is basically between these two tick marks right here. You go down, the blues and the purples, strong easterly anomalies. Right there, that's probably the peak of the inactive phase of the MJO, let's say 18th of January. And here we are moving into current time, right? There's today's date. You see easterly anomalies still in control, but moving out of the Kelvin wave generation area. There's the date line right there. So still maybe barely in the Kelvin wave generation area for 3 more days. Then you see here is reds. That is westerly anomalies in the Indian Ocean, but moving steadily off to the east. And a week out, we see westerly anomalies moving to a point south of Hawaii. All this is on the equator, mind you, suggesting the active phase of the MJO is to be making good progress into the Pacific, not only the West Pacific, but maybe even towards the East Pacific. California's at 120 west, so when the active phase moves this way, then the thought is precipitation comes with it. So let's go take a look at outgoing long-wave radiation models. And as usual, the reds and orange suggest areas where there's a lot of sunlight reflectivity off the ocean surface, meaning high pressure, meaning the inactive phase of the MJO. All right, so there's Hawaii, there's Mexico, South America, Australia. What this looks like is right there, right at 150 south of Hawaii, 150 west, that's where the core of the inactive phase of the MJO is today. And the active phase of the MJO is building strongly over New Guinea. That's pushing its way into the West Pacific. Looking down 2 weeks, you see the active phase of the MJO making steady westward progress. Inactive phase of the MJO, and only on the equator, that's what we're concerned with, is all but gone. This is a good sign. That's 2 weeks out. This per the statistical model. The dynamic model, basically the ensemble GFS model, says basically the same thing, only that the active phase of the MJO is to be stronger still, pushing to a point just about south of Hawaii. So the active phase of the MJO appears to be moving in the right direction and fairly quickly. And then upper level model. So this is up at jet stream level, and the greens suggest areas favorable for precipitation. Notice this is strong green and with a white core, meaning supposedly off the chart strong. Right? Oops, you can't see that. There you go. Off the chart strong. So strong active phase of the MJO forecast in control of the West Pacific. And now this model runs about a week or so ahead of what actually happens down at the surface, a week to a week and a half. But anyway, active phase moving across the Pacific and getting, we'll say right somewhere in here, February 12th, February 17th, getting good purchase south of California. So that's probably when one would expect to start seeing some precipitation, perhaps moving into the southwestern U.S. if it's going to. But also notice the inactive phase of the MJO starts taking root in the West Pacific February 12th and making its cycle across the Pacific. So it's during this active phase when we get some storm development. We'll say the month of February, probably the early to mid part of February, better odds for storm and swell development. And then as the inactive phase takes control later February into early March, things die out. And then our favorite model, the CFS model, 850 millibar wind anomalies. Here we are. The forecast moves forward. date line, you can see it right there, is there a Kelvin wave generation area basically between here and here going up this way on the chart. And you can see as of today, westerly anomalies building in the far west Pacific, easterly anomalies in the east Pacific, but you can see by 4 days out or so, the pattern is supposed to change significantly. Let's overlay. There we go. See, the solid contours are the active phase of the MJO. So you see the active phase of the MJO as of today, already building in the West Pacific, supposed to be strong and in control, we'll say the first to second week of February. And then, let's see, there's California right there, reaching into California, February 8th or so. Westerly anomalies filling the entire Pacific Ocean. This would be a rare treat if this were in fact to happen. It looks like a pretty strong active phase of the MJO. And then as expected, as we get into later February, inactive phase, these dotted contours, the inactive phase of the MJO taking over the West Pacific. But even then, west anomalies hanging on until about the second week in March, and then easterly anomalies build. That will certainly shut down the jet stream, split the jet stream. But then when we get into early April, active phase of the MJO fires up again. Strong westerly anomalies forecast over the dateline. Maybe a late season push of swell as we get into spring. Hard to believe any model this far out, but it's a nice little tease. Let's add the low pass filter, see what's going on. You can clearly see as we get into somewhere around March, see the solid contour? This is the area biased towards low pressure. We'll call it the El Nino sort of signal, moving stronger into the West Pacific. And where's the date line? Right about there. And over the date line as we get into April, and then this area, the La Nina signal, the area biased in favor of high pressure, right now is still covering 50% of the Kelvin wave generation area. But as you get into about the first to second week in March, it's gone. And so one would say somewhere around mid-March, a pattern shift is possible to set up more favorable towards storm development and possibly signaling the demise of La Nina in the Pacific. And then phase diagram charts. These are interesting, especially this week. So you know how this goes. This chart, assume you're looking down on the North Pole, and the active phase of the MJO moves from west to east, from the Indian Ocean over the maritime continent, over the dateline into the west, in the West Pacific over the dateline, under the United States, across the Atlantic, over top of Africa, back to the Indian Ocean. Right now, the heavy dot shows where the active phase of the MJO is in phase 5, roughly somewhere in the extreme far West Pacific. But the thing to notice here is if the dot is very close to the circle, it's very weak. If it's out here, it's pretty darn strong. And then when you get out to the outer reaches of the chart, incredibly strong. So notice the active phase of the MJO is to still be building in strength as it pushes over the West Pacific. What's that, 4 days out? And then make it there and then start weakening per the ECMF model, but over like the date line almost into the Eastern Pacific, whereas this, the GEFS model suggests an incredibly strong active phase in the far West Pacific in the next 5 to 6 days and basically holding there. So that is, if this comes true, or even this, which isn't horrible, suggests a good building pattern favorable for storm development. And then this chart depicts the strength of the active phase of the MJO. Does not say where it is, but you can see here we are, January, a building compared to last spring and all summer where we had no MJO signal. Now we are having this continual sort of weak to moderate active MJO signal starting to show up and building as of just the last day or so. This little spike here, we'll see where this goes, but the thought is that there should be more width in this signal in the next coming 2 weeks. All right, let's look longer term, more like a El Nino, La Nina sort of time frame. First off, we start looking at subsurface water temperature profiles, West Pacific here, East Pacific here. This is the surface, working your way down into the ocean. These are the anchor lines on the TAO buoy array. The X's are the sensors on the buoy lines. We see warm water, 29 degrees Celsius in the far west Pacific. A thin, shallow pool of warm water in the East Pacific, pretty much typical of La Nina. Now, here's the interesting thing. So last week we had a strong finger of 2-degree anomalies pushing from the West Pacific. Oh, these are anomalies, differences from normal for this time of year. This strong finger was almost, one would say it's a Kelvin wave. Well, it's sort of broken apart. We still have a little pool now, so this was reaching almost out into here a week ago. There's a little bit of it left, but the good news is what this is doing, this subsurface warm water pushing off to the east, is helping to erode the cool pool that's been in play for a year over or so here in the East Pacific, trying to return temperatures back to normal. We're not there yet, but it certainly suggests that maybe La Nina is taking a bit of a hit. Another version of that chart using a different model to map it still looks very much like, almost like a Kelvin wave was developed, is pushing off to the east. There's your cool water in the East Pacific, limited now to just a shallow area on the surface and in the far, far East Pacific. Certainly early, let's say a month ago or so, this area was much more expansive, suggesting that La Nina also is taking a hit. Upper ocean heat anomalies, upper 300 meters of the ocean over time. Last February, you see warm water in the West Pacific, fingers of it, almost Kelvin waves, very weak Kelvin waves, pushing east, impacting Central America. Not quite an El Nino, but certainly a eastward transport of warm water. And then in August, our El Nino developed fully cool anomalies in control. But notice here, just in January, now you see warm water working its way off to the east, at least cutting a good hole into La Nina for the moment. Let's take a look at the surface water temperature anomalies, differences from normal for this time of year. So last week we saw warm water building out here. And yes, there was this cool water along the coast of Peru, not as pronounced last week as it is now. We see a return of upwelling all along the coast of Chile and Peru, pushing off. Remember, high pressure is here, rotating counterclockwise, pushing cool water or feeding upwelling along the coast, and then that starts pushing off along the equator. So the thought is, with the inactive phase, so we had it, let's go back a little bit, a couple weeks ago, we had an active phase of the MJO that created warm water that pushed subsurface, almost a Kelvin wave, sort of cut into the cool pool, kind of shut things down. We started getting some warming building. Now trades building again because we're in the inactive phase of the MJO. High pressure builds during the inactive phase. That causes upwelling. So we get a little bit of a resurgence of cool water. The question is, how long will this last? Well, if the models are right and the active phase of the MJO is coming, and coming pretty strong, this probably won't last very long, and La Nina will continue to get eroded. 7-day trend, you see warming off of Chile and Peru. Light warming, not as strong as it was, but clearly no cooling, and just the faintest little pockets of cooling on the equator. Generally a warming trend. As of right now, it looks like La Nina is taking a hit. But that was just the 7-day trend. Let's put things into perspective. The gross overview picture still shows a well-defined, clear pocket of cool water on the ocean surface. The main Nino monitoring region, the Nino 3.4 region, is right here from 120 west out to 170 west, 5 degrees north and south of the equator. You can see nothing but cool anomalies here. In fact, let's go look at the temperatures. And here is the CDAS Nino 3.4 index. You can see, so all you have to be is half a degree below normal for La Nina to be declared. We've been there and holding there all November, December, into January. This is when it looks like it peaked out somewhere around, January 8th or so, down to a 3-day, 4-day run about a little minus 1.6 degrees. But then we rebounded. Remember, we had an active phase of the MJO. Temperatures are up, still up as of January 28th at about a half a degree, 0.488 of a degree below normal. Still clearly in La Nina territory, but certainly not building. And if anything, it appears that it's weakening. So let's take a look at the atmosphere and see what effect those cool waters in the Nino 3.4 region are having on the atmosphere. One way to do that is look at the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. When you have negative numbers in the daily index, that suggests, and it's actually a trend, that suggests the active phase of the MJO. But when you have a long run of positive numbers, like we're having right here, today's value is at 12.02. You can see it's been up to 25 and been hovering positive since mid-January. That suggests the inactive phase of the MJO, and we know that to be true. You look at the 30-day average, that's a good way to sort of pick out the trends. There's a lot of noise daily in these values, but over 30 days, you can see we went from the active phase of the MJO, and now we're turning positive towards the inactive phase, but we also know that right around the corner, the active, I said the inactive phase, I hope I did. From the active phase to the inactive phase, we also know that right around the corner, the active phase is getting ready to return. Now, we look at the 90-day average, and we can use that to say, are we in El Nino or La Nina? Positive numbers suggest La Nina. Yes, we're positive, but notice, not particularly strong, only 4 or 5, a reading of 4 or 5. That's a pretty weak La Nina. And the suspicion is, from all the data that we just reviewed, is that La Nina is already starting to fall apart. This could be good news. But there's always something that messes up the good news, and it is the ESPI index. And so instead of measuring atmospheric pressure, you measure precipitation, and specifically the precipitation south of Hawaii, north of Tahiti, in here. If the index is negative, it means that there's less precipitation here than normal. And this is like a 3-month leading indicator of what's going on. And right now, it's falling, getting more negative. It was at minus 0.88, I think, a couple of weeks ago, and then it went to minus 0.9. Now it's down to minus 0.1, suggesting that, of course, the cool water here, that, of course, inhibits evaporation and that therefore inhibits precipitation. So maybe it's hard to say what's going on here, but as of right now, just looking at the index at face value, it is not getting closer to neutral or going anywhere near positive. It's staying negative, suggesting La Nina wants to hang on for a while. And the Nino 3.4 forecast from the CFS version 2 model. So here we are right now, somewhere in January, sea surface temperatures in the Nino 3.4 region, half a degree below normal. That's about where we are. Supposed to warm up some, but this model takes a definitely negative view, suggesting La Nina is supposed to rebuild into April and through the summer with temperatures down to, what's that, about minus 0.8 degrees and floundering somewhere around there in the 0.7 degrees below normal into the fall, suggesting La Nina will continue. So let's put things in perspective. This is all the models that exist that are used for modeling El Nino, La Nina, and the model we just saw, the CFS version 2, is the green. There's the green. It suggests that that model is the most negative of all of them. This is the mid-January plume. It suggests all the other models are basically saying a return to normal or slightly warmer than normal pattern as we get into midsummer. The consensus is this blue line here, suggesting ENSO neutral by about April, May, something like that. So we're not going to get too disheartened yet, because the CFS model appears to be, for whatever reason, the outlier. The question is, how good are all these other models compared to the CFS model? I guess we're going to find out as we get into the next several months. So for the immediate future, a building storm pattern, not particularly huge, but certainly in close proximity to Hawaii, over the date line, let's say. Building surf for the Hawaiian Islands, probably sideband energy expected, eventually reaching the U.S. West Coast. The issue for Hawaii is, of course, going to be weather and wind. The U.S. West Coast, certainly not weather, certainly not wind. but because the storm center is so far away, the swell will be much smaller. But when it does arrive, it will be groomed, so small, groomed surf is probably the outcome for California and the rest of the U.S. West Coast. Unfortunately, no rain in the immediate forecast. High pressure rules supreme. But looking longer term, MJO is supposed to turn active, pretty strong, and pushing towards the U.S. West Coast. The thought is, at some point in February, a pretty healthy storm pattern might result, bringing precipitation and, of course, snow to higher elevations. Long term, kind of unsure, though the consensus models suggest that La Nina is dying and that by this summer we'll return to a normal state. That would be good, and then we'd be back in business, hopefully the storm track returning to normal, and plenty of surf, hopefully on track for the summer. So that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.